Good morning, students. Today we are going to study about hypnotic and sedatives. Till now, we have studied drug acting on CNS, means the drugs which are affecting CNS system. These drugs we have done general anesthetics, and in hypnotic and sedatives we have covered till now barbiturates. Now, next category is benzodiazepine, which we have to study in this video. So, what is benzodiazepine? And what are the effects of benzodiazepine? Benzodiazepine have sedative, hypnotic, anti-anxiety, anti-convulsant, and muscle relaxant properties. They are most widely used anxiolytic drugs, means they are used to treat anxiety and insomnia. They are also used in wide range of other neurological conditions. Benzodiazepine have largely replaced barbiturates. It became a gold discovery when benzodiazepines are discovered, and methylbarbamate is used in the treatment of anxiety because it is a safer drug and it is less side effect, and dependency is more likely less as compared to barbiturates. This is the advantages of benzodiazepine over barbiturates. They are more safer. They are used to treat anxiety similarly as that of barbiturates, and they have less side effect and dependency as compared to barbiturates. At low doses, they are useful in sedatives, and at high doses, they are used to produce hypnotic effect. When we talk about the absorption and distribution of benzodiazepines are lipophilic in nature. This we already have discussed. For a drug to be active in CNS means a drug should have lipophilicity. The drug which can easily cross blood-brain barrier, that drugs can only affect CNS. Otherwise, the drug which is not able to cross blood-brain barrier, that cannot able to reach to the CNS, and they are rapidly and completely absorbed after oral administration through distribution throughout the body. Benzodiazepines. Next is the excretion of benzodiazepines. Benzodiazepines are excreted in urines as glucuronide and oxides metabolism. Next, the derivatives of benzodiazepine, Valium, which is now known as diazepam, is discovered in 1962. It has a characteristic of 7-membered ring. This is a special type of a structure. Till the discovery of the benzodiazepine, it is the only structure which have a 7-member ring. It is used to treat anxiety of all kinds, such as phobia, preoperative anxiety, myocardial infarction. It is also used for the prevention of cardiac stress due to anxiety. The next thing is mechanism of benzodiazepine, means how benzodiazepine act. Benzodiazepines work by enhancing the effect of neurotransmitter. That is, which neurotransmitter it act on a gamma, that is gamma aminobutyric acid, which is responsible for reducing activity of neuron that cause stress and anxiety. This particular receptor, GABA, is an inhibitory neurotransmitter, and it is used. Why it is used? It causes the stress and anxiety in human being. So this this neurotransmitter is suppressed or enhanced by the benzodiazepine. Next, if we talk about the chemistry or the structure of benzodiazepine, it contains heterocyclic system, which is a fusion between benzene and diazepine rings. If we look at the structure of the benzodiazepine, this 7-member ring which contain 2 heteroatom, nitrogen and nitrogen, this is called diazepine ring and it is fused with the benzene ring. This heterocyclic cycle has 2 nitrogen atoms, 5 carbon and maximum possible number of cumulative double bond. Benzo prefix benzene ring is fused onto a diazepine ring. That's why it's named as benzodiazepine. For a benzene, the prefix benzo is used, and for diazepine, the other nucleus is named as a diazepine. Now, in this structure, this R is labeled. This R denotes to the common location of the side chain. Means here the further substitution can be occur, which will form a derivatives of benzodiazepine, which gives different benzodiazepine with their unique property. If we look at the right structure, this structure is named as 1,4-diazepine ring system. And if we look at the right structure, it is a structure of the basic diazepine. Hello. Next, this is the structure of the benzodiazepine. If we look at the structure of the benzodiazepine, at the 7th position, there is the substitution of the chlorine group, and at this is the structure of diazepam, which is commonly called as valium. But now next, what are the different types of benzodiazepine? Means different derivatives of benzodiazepine. There are many different derivatives of benzodiazepine. There are many different benzodiazepine and they have all difference in potency. Means because of the different substitution in the diazepine rings, they have different potency and speed of metabolism, that is half-life required. Half-life means time required for the quantity of drug in the bloodstream to decrease to half its value, and therapeutic use. Different benzodiazepine vary mostly in their durations of actions. At the position 7 substitution, such as halogens or nitro group is required for to have a diazepine, a sedative and hypnotic activative. If we look at the structure of the benzodiazepine, in clonazepam at 7 position nitro group is attached, and in diazepam and lorazepam chlorine group is attached. In case of the flunitrazepam, nitro group is attached, and these are the different substitutions and other different substitution in case of the different diazepine. Now, these are the different structures of the benzodiazepine. If we look at the structure of the diazepine and chlordiazepine, chlordiaxopoids, there is a only difference at the here the carbonyl moiety is replaced by the methyl amine, and in case of the diazepoxide, the nitrogen is coordinated bond with oxygen. And these are the different structures of the diazepines, benzodiazepine, diazepine, chlordiazepoxide, flurazepam, desmethyl diazepam, oxazepam, lorazepam, nitrazepam, triazolam, and alprazolam. Now, next drug which we have to study in detail is nitrazepam. It is different from diazepam in having nitro group in place of chlorine group at C7 position. If we look at the structure of the diazepam, here is the chlorine group is attached. And if we look at the structure of the nitrazepam, in place of the chlorine group, nitro group is attached. And H atom instead of methyl group at C1 position, at first position. And methyl group is attached. And hydrogen group is attached in place of the methyl group. If we talk about the physical properties of nitrazepam, it occurs as yellow crystalline powder. It is odorless and almost odorless. It is practically insoluble in water, means water में solubilize नहीं होगा, slightly soluble in alcohol. Now, if we talk about the stability and storage of nitrazepam, it is degraded by moisture and sunlight. Therefore, it should be stored in a tightly closed light resistance container. Next is the uses of nitrazepam. It is used as hypnotic and sedative. It is also used to treat insomnia. It is also used to treat some forms of epilepsy, such as myoclonic seizures. These are the, and if we talk about the formulation of nitrazepam, it comes in capsules and tablets, means for oral formulation. And this is the brand name of the nitrazepam. Next is the drug contain. Next is a class of drugs which contain amides and imides. And in this, we have to study about glutamide. Glutamide, if you look at the structure of the glutamide, it contains piperidine ring, which is substituted with ethyl and phenyl at C3 position. Now the chemical name of the glutamide, which is 3-ethyl 3-phenyl piperidine 2,6-dihone or alpha-ethyl alpha-phenyl glutamide. Now, if we look at the physical properties of glutamide, it occurs as white powder or colorless crystal. It is colorless and it is odorless and has bitter in taste. Now, next is the physical properties of glutamide. It occurs as white colored powder, or it also may be present as colorless crystal. It is odorless and has bitter taste. If we talk about the stability and storage of glutamide, it is affected by air, moisture, and light. Therefore, glutamide is stored in tightly closed container to prevent from air and moisture. And therefore, it should be stored in tightly closed container to prevent from air and moisture, and to prevent from light, it should be stored in light resistance container. Now, if we talk about the uses of hypnotic and sedative, it is used to treat, it is used to induce sleep. It also being used to relieve anxiety and tension. If we talk about the formulations of glutamide, it is used to, it comes in the tablet and capsules form. This is a brand name. Now, next drug is the methylpyrrole. Methylpyrrolone. It is different from glutamide in having 4-oxo group in place of the 6-oxo group. Means if we look at the structure of the glutamide, there is at 4th position there is an oxo group attached, and in case of the methylpyrrolone, there is the oxo group is attached at 4th position, and methyl group is attached at E5 position. Now, next is the physical property of it is used as white crystalline powder. It has slightly characteristic odor and burning sensational taste. It has bitter taste. It has aftertaste, which is a bitter taste. It is insoluble in water and very soluble in alcohol. Next is the chemical properties of methylpyrrolone. When its solution in sodium hydroxide is treated with potassium ferricyanide, it shows a green fluorescence in ultraviolet radiation. Now, next is the stability and storage. If we talk about the stability and storage, it is also affected by air, moisture, and sunlight. Therefore, to prevent from the air and moisture, it should be stored in a tightly closed container. And to prevent from the light, it should be stored in a light resistance container. If we talk about the uses of the uses of this drug, it is used to treat hypnotic and it is used to treat insomnia and produce sedative effect. It is a non-barbiturate hypnotic and sedative. And next is the formulations of this drug. It comes as tablet and capsule, and this is a brand name for this drug. Next is the alcohol and its derivative. In this, triclofox sodium is the drug which we have to study. If we look at the structure of this drug, it contains 3 chlorine groups. It is a phosphate ester of trichloroethanol. It is a prodrug, and in body it is rapidly hydrolyzed to give trichloroethanol, which exhibits as hypnotic and sedative activity. Now, next is the physical properties of triclofox. It occurs as white powder, which is hygroscopic in nature. It is odorless and has slight taste. It is freely soluble in water but slightly soluble in alcohol. Next is the aqueous solution has acidic pH, means its aqueous solution show acidic pH. Next is the chemical properties of triclofox. Now, if we look at the chemical properties of triclofox, when this is heated with anhydrous sodium carbonate, chlorine combines with sodium to give sodium chloride. This is the reaction triclofox sodium heated with anhydrous sodium carbonate. It produces sodium chloride. This reaction is used for the assay of means to find the percentage purity of triclofox. Its aqueous solution decomposes slowly and liberate chloride and phosphate ion. Next is it is rapidly hydrolyzed in stomach, means in acidic medium, and to give trichloroethanol, and which is rarely absorbed. Next is the stability of this drug. It is hygroscopic and decomposed by air and moisture. Therefore, it also stored in tightly closed container to prevent from the decompositions by air and moisture. Next is the uses. It used as a hypnotic and sedative. It is also preferred to chlorhydrate, means peraldehyde, as hypnotic and sedative because it is more palatable. It does not cause gastric irritation. It is a stable compound. It is not corrosive to skin and mucous membrane. These are the formulations of triclofox. It comes as elixirs and syrup, or it also comes as tablet. This is the brand name for triclofox. Thank you. I hope this video is informational for you.